Today I'm going to take a couple minutes to review what we did in class, which was dealing with a point given on the terminal side of an angle in standard position, and we're going to find the trig values. Okay, so as you know, I like to have a picture, so I'm first going to draw myself a picture, and I'm going to plot the point -6 and 9. And it doesn't have to be exact, you can kind of make a decent sketch, right? So standard position, vertex on the origin, and then point P is on the terminal side. So here's point P. Okay. And if I'm going to find the trig functions, we know that they're right triangle trig. So that means we need to in some way have a right triangle. Okay. And so here's our theta. Now remember in class we said that the sine of theta is the same as the sine of the reference angle, and the same is true for cosine and tangent. So if let's say this was an angle of 121, then sine of 121 would be the same as the reference angle, which would be the 180 minus 121, except for perhaps the sine, S-I-G-N. Okay. So we know that this length here is 6 units. We know this length here is 9 units, and we need to find the length of the hypotenuse, and in class we called it r. Okay, so we said that we would do that using Pythagorean theorem. So I'm going to have my 6 squared plus 9 squared is equal to r squared. 6 is 36, 9 is 81, and that's equal to r squared. So in order to find what r is, we'll take the square root of that. And so we have 117. The square root of that is what r equals. Okay. Now, before we write that down, we're going to see if 117 can be expressed in a simpler form. So I'm going to remind you of something that you did last year in geometry and we reviewed in class. If you go to the menu on the calculator and number 2, you can factor. And so we can factor 117, it'll give us the prime factorization. So if I see any numbers with an exponent of 2 or more, then we know it has a perfect square factor. So in this case, we can simplify 117 to 3 radical 13. And now that we know all of the lengths of the sides in this right triangle, we will be able to calculate the 3 trig functions. So sine theta is opposite over hypotenuse. So we have 9 over 3 radical 13. And then we just have to decide the sign, S-I-G-N, whether or not it's positive or negative. And we can do that by considering the x value or the y value. So in this case, we have a negative x, positive y. And in class, we said that sine is representative of y. And since y is positive here, sine will be positive. Okay, I'm not going to let you leave your answer as 9 over 3 radical 13. So we can go ahead and simplify. So I have 3 over radical 13. And then, of course, I have to rationalize my denominator. So I'm going to multiply by radical 13 over radical 13 to get a final answer of 3 radical 13 over 13. Remember, a radical times itself is the radicand. So the only thing that kind of cancels, which is what I saw some of you doing in class, is the radical, and you're left with the radicand. Okay, next we'll do cosine, and cosine is adjacent over hypotenuse. So we have 6 over 3 radical 13, and since cosine is the y value, we know that's going to, or excuse me, the x value, we know that's going to be a negative, and then we're going to go ahead and simplify. So 3 can go into 6 2 times, and then we'll multiply by radical 13 over radical 13, and we'll get a final cosine value of -2 radical 13 over 13. And 2 and 13 do not have any common factors, so we're as simple as we can be. Lastly, we have tangent, and tangent in this case is the easiest because we are already given the opposite and the adjacent side. So we have 9 over negative 6, or negative 9/6, and you can leave it like that, or you can reduce it to simplest form. So that means they have a common factor of 3. 3 goes into 6 2 times, 3 goes into 9 3 times. So we have tangent equals negative 3/2.